Yes, what do you understand from power, please?
So it's like basically like the number of times the number is repeated.
Yes. It is given in your book repeated multiplication of a number by itself, right?
Yes.
What does that?
Power.
Repeated, yes, repeated multiplication of a number, right?
Yes.
By itself. So how are we going to express it? See what expression you can use here for this thing. Suppose I'm writing x, right?
Yes.
X to the power n. X to the power n. So what terms we can use here? Generally in junior classes we go with this thing. Whatever is raised on the top right hand side, that is called power. But in this chapter, what actually power means, this entire expression. Got it? Or you can say the resultant value. Understood?
Okay. Yes, ma'am.
So what we are going to call this raised thing? Exponent, you can say. Right? Or you can say index or
Okay.
indices, right? So this will be called exponent. This x would be your base, right? And the whole expression, this entire expression, or the you can say the resultant value, right? That would be your power. Got it?
Yes, ma'am.
Understood? And now the question is, how do we check the power play of any number? By folding the paper. Okay, that we will be discussing later. Okay, now what else is there? Some properties are there. Do you know the exponent properties, laws of exponents?
Uh,
Okay, do
yes,
you
ma'am.
know? Yes.
Like uh, if it's like x, so it's the same number and the power is different. So and you have to divide it. You just subtract. You put the same power and you just subtract the powers.
Very good. One more thing is given in your book. See, they said if we have to check the power play, generally we check it with the folding of paper. Okay, and maximum how many times you can fold any paper? That is maximum 7 times. Okay, if you want to check it, you can do it in practical. Any paper you can take, right? And you can try folding it. You cannot fold the paper more than 7 times. Got it?
Yes.
And what is there? They said whenever paper is folded, how we are going to check the thickness? It shows the exponential growth, right? Since we have used this for this raised value, we have used the word exponent. So it says whenever paper is folded, it shows exponential growth. So what do you understand from exponential growth? Have you heard this term before?
No.
If you haven't, I'll explain, right? Do you have any idea about or whatever you are getting from this word? What do you think? What could be the exponential growth?
Um, we can
Yes,
uh,
yes.
the exponential form will basically be the exponential growth.
Means power will increase or
Ye-
value will increase,
yeah,
right?
the
Yes,
power,
value will.
the quantity increased like in a fixed percentage.
Yes, yes, you are right. Suppose if you are given any number 4, right? So what would be the exponential growth of that number times in times, right?
Yes.
If we recite the table of 4, how we can show the exponential growth? 4 ones are 4 or 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, and so on, right? So this is called exponential growth. Got it? When you multiply the values. Understood?
Yes.
And how the paper get increased by, yes, what power do we use for the increase in thickness of paper? Or how many times? When you double the paper, right?
Yes.
Suppose you are folding a paper, so it will get doubled. So how you are going to express your power generally? You will be writing like this: 2 raised to the power n, right? And whatever would be the thickness of the paper, that would be written here. Got it? Generally, we express this exponential growth this way. Suppose you have been given thickness of any standard paper. So if I say, if I give you condition, okay, the paper is folded 50 times, right? Or if I say 40 times, how you are going to check? And suppose I am giving you thickness is 0.001 meter. Okay. Suppose this is the thickness. How you are going to check? You will be multiplying 0.001 with this thing, base thing, and you will get the thickness after folding paper 40 times. Understood?
Yes, ma'am.
This is just an example. Okay, later we will be doing numericals on this. Okay, one more thing is there. We have discussed exponential growth. What is linear growth? Have you heard of linear growth? What, or you can say, what is the difference between linear growth and exponential growth? Linear growth?
Ma'am, linear growth is basically like, let's say, it is a increase in the quantity.
Yes, very good. You can tell it in the, see, in both the terms, the value is getting there is acceleration, right? In both the terms. So you
Yes,
can differentiate them with the operators. If I say, okay, in exponential, we use multiply, right? This operator. So what operator we can use for linear growth? So signifies increase, right?
yes.
And both the value is increasing. So what operator you can use for the linear growth here?
Addition or
Yes,
multiplication.
yes, very good. Addition. Great.
Yes,
And how we are going to plot the graph? Linear, we are saying. So we can basically go like this, right? And for the
yes,
exponential, since the value is multiplying, so it would be like this. Am I right? Fine.
yes,
So what is asked here? How to check thickness of paper, right? So that
yes,
we would be writing. How to check thickness of paper?
yes,
How to check thickness of paper after folding, right? This is the question. So how you are going to answer? Thickness, I'm writing it in short. First condition is you will be checking the thickness of paper after folding through exponential growth, right?
yes,
First condition is this. And why do we use the base 2? Because the thickness doubles, right? Whenever you fold any paper, you keep on folding, so it will be doubled, right? Suppose if it is 2, it will become 4, then 8, then 16, like this. Got it?
yes,
Understood? This way. And what expression you would be using here? T n is equal to 2 0, right? Got it? Tn is equals to 2 0 and into 2n. See, they have given 2n. This we have already discussed, right?
yes,
Now the question is, what does 2 0 here means, right? That is the initial value, initial thickness, whatever was there, right?
yes, ma'am.
Or initial value, you can simply say. Initial thickness, and Tn is the final value, right?
Yes,
And would be your final thickness that you would be getting. Understood? This is to check the thickness of paper.
oh, okay, ma'am. Yes, ma'am.
Have you understood this base too? Because whenever you will be folding the paper, the value will be doubled or thickness will get doubled, right?
Yes,
In exponential form, you have to express, right?
yes. Oh, ma'am, 1 second. I just lost my page. 1 second.
It's okay. It's okay. 6 into 6 into 6 into 6.
Yes, good. So this will be 6 on the to the power of 4.
Yes, very good. 6 to the power of 4. Or what would be the exponential value? You can say it would be 4, right?
4. Yes.
Is it right?
Yes, ma'am.
Okay. Are you done? Can I insert a page here?
Yes, ma'am, you can.
Okay. What next value is given to us? That is y into y. Y into y. So how we are going to express it in exponential form? Says y into y.
Um,
What would be the power we
so
can say,
that
right?
would be y to the power of 2.
Next one is what next value is? Okay, I'm writing all the values. You can solve and then you can tell me, right?
Yes.
If you have any rough notebook in handy, you can solve over there and then we will be discussing it quickly, right?
Yes, ma'am. I'll
Or
just do.
okay. Yes. 55777. First one given to us is 22 AA.
Yes, ma'am.
Triple A, triple C, D, right? Triple A, triple C, and D. Yes, these are the values. Shall we start?
Yes, ma'am.
Okay, what does B times B this?
B times b to the power of 4.
Yes, very good.
Then it
5
is
times 5
5 to the power of 2 into 7 to the power of 3. So which is 5 square into 7 square.
to differentiate this operator, we will be using dot here, right? Since we are
Yes.
writing it in exponential form, so we will be ignoring the operator and we will be writing, means we will be replacing the operator with dot, right?
Yes.
What does 2? 2 to the power of what?
To the power of that is gonna be to the power of 2 and a to the power of 2 again.
Yes, very good. For the last one,
Yes.
three alphabets, right?
Yeah.
Or variables, you can say A, C, and D.
A, C, and D.
But what should I write for these? A
For
times
that,
A times.
a to the power of 3 into c to the power of 3 and into d.
A times A is A3, right? C
Yes.
times C is C3, like this, right? Now let's jump on to second question. Yes. What is given? First you can read, then we will start solving, right? Express each of the following is a product of power of their prime factors. Okay. See, okay. First read this question, then we will discuss, okay?
Okay.
Express each of the following is product of powers of their prime factors.
Yeah.
Express as product of powers. Product of powers of their prime factors. Have you understood? Have you got what they are asking for?
Yes, ma'am.
Okay, will you try?
Yes, ma'am.
Or you want me to solve first one for you? What do you say? Should I solve first one for you?
Yes, ma'am. Can you like give like solve it for like an example question?
Yes, I'll give you one example, right? See, we have to do prime factorization of 648. So I'm doing it quickly, right? 2 3s are 2 times 3 is 6, 2 times 2 is 4, 2 times 4 is 8, like this, right? 2
Yes.
1s are 6, 2 8s are 16, 2 9 is 3 2s are 6, 3 7s are 11, 3 9s are 87, 3 3s are 9. Got right? 2 2 2 3 3 3 3 2 to the power 3 and 3 to the power 4. What is the next value? 405.
Yes.
Means we have to express it in exponential form, provided the base values should be prime factors, right?
Yes.